We're now going to talk about confidence intervals for sample means. And in this case, we will know sigma, or the population standard deviation. So for example, if we wanted to estimate the average ACT score for high school students or for Osceola students, that we could do that using a confidence interval. Same thing as proportions, same overall idea, just in this case we'll be dealing with quantitative data. IQ scores, things that are measurable. Okay. So, quick review on your formula sheet. Again, you have the general formula for a confidence interval, which is the statistic plus or minus the critical value times the standard deviation of the statistic. And we're dealing with sample means in this case, so we have this formula, which again should look familiar. It's pretty easy, sigma over the square root of n. Okay, so again, we're talking about sigma known here, and we're going to estimate mu, the true mean of some data. Bad news, we got conditions again. You must check them every time. They're the same three conditions, SRS, normal, and independent. However, there's a slight difference for the middle one, normal. Okay, so SRS, the data must come from a random sample. The population needs not to be, well, either the population's normal, population must be approximately normal, or n is greater than or equal to 30, and that goes back to the central limit theorem. Even if we've got skewed original data or population data, if we take samples that are bigger than 30, then it'll still be approximately normal and we're okay. And independent, again, is population greater than or equal to 10n. Okay, so we have our formula for the interval. We go back, it's the statistic plus or minus the critical value times the standard deviation of the statistic. And in this case, it's x bar plus or minus z star times sigma over the square root of n. And now I'll walk through an application of using that formula. So let's say that we wish to estimate the average cost of a 32-inch flat screen TV. We randomly select 50 TVs from various retail stores throughout Florida and find the sample mean to be $435. Suppose it is known that sigma equals $110. Construct and interpret a 99% confidence interval for the mean price of a 32-inch flat screen TV. Okay, so very similar to the proportion problem, we walk through the beginning. We want to identify the population, which is all 32-inch flat screen TVs. The parameter of interest, what we are trying to estimate is the cost, or the average cost, let's say. Average cost of 32-inch TV. We don't know that number, so we're using a confidence interval to predict that. Now, I'll label some variables. X bar, $435. Sigma is $110, and n equals 50. 50 TVs, there's your X bar, and there's your standard deviation. Okay, so we check the conditions. The boring part, but we got to do it every time. Simple random sample, and in this case, it's stated. We randomly select 50 TVs. So we can just say stated in problem. Okay, that condition is met. Number 2, either the population is approximately normal, or n is greater than or equal to 30. And in this case, 50 is greater than or equal to 30, so central limit theorem applies, and I can use my normal calculations. The last one is independence. And this is basically saying that one TV is independent of the next. It doesn't, and that's why we want to make sure that the population is greater than or equal to 10n, greater than or equal to 10 times 50, which is greater than or equal to 500. And I'm going to go ahead and assume that there are more than 500 TVs, flat screen TVs out there. Okay, so now we're done with the conditions. We can move on to the fun part, the calculations. Alright, first off we name the formula. This is a one sample Z interval for means. And we write the formula down, x bar plus or minus z star sigma over the square root of n. Now, a little reminder, z star for 99%. And again, I got that from the problem. Right here we have a construct and interpret a 99% confidence interval. So z star for 99% is 2.58. And now we plug and chug. X bar was 435 plus or minus 2.58 times the standard deviation, which was 110, divided by the square root of 50. Now, I like to do that calculation separately so I don't mess up in my calculator. And I'll have 435 plus or minus 2.58 times the standard deviation, which is 15.56. 435 plus or minus, multiply those two numbers together, I get 40.14. Friendly reminder that that's the margin of error. Alright, that 40.14. Subtract it from 435, I get 394.86. And added to that number, I get 475.14. And that's the math part. And then the last thing I need is my conclusion, which again is my interpretation of that interval. Okay, so we are 99% confident that the true mean or average cost of a 32-inch flat screen is between $394.86 and $475.14. And that is the conclusion. Now, remember that that's not saying that 95% of TV or 99% of TVs are in between those two prices, but that 99% of all the confidence intervals that we were to construct, 99% of them would contain the true mean.